Hi, in this video we'll learn how to divide complex numbers. So the first thing we need to keep in mind is we cannot have an imaginary number I in the denominator. I have an I in the denominator and I need to eliminate that from the denominator. To do that, I'm going to multiply my fraction. I'm going to multiply my top and bottom by I. And I'll let you know why I multiplied by I in a bit. So I'm multiplying my numerator and the denominator by I. Now I'll put a parenthesis around this because we need to distribute this I inside the parentheses. So let's use the distributive property to distribute I inside the parentheses. So I times -5 will be equal to -5I. I times -I is going to be -I squared. Divided by -10I times I is going to be -10I squared. Now we know that I, imaginary number I, is equal to square root of -1. And if I square both the sides, then this will be I squared on the left hand side. On the right hand side, the square and the square root is going to cancel out each other, and I'm only left with -1. So now I know that I squared is equal to -1. Now we're going to substitute -1 for I squared in this expression. So let's do that. This will be equal to -5I minus I squared is -1, so I'll plug in -1 here, all over -10. Again, in place of I squared, we'll plug in -1 here. Now let's simplify this. This is going to be -5I, and then negative times negative is going to be positive, and then I have 1 here divided by -10 times -1 is going to be +10. Now, if you notice that I don't have the imaginary number I in the denominator, this was the reason that I multiplied my fraction by I, because I know that the value of I squared is equal to -1, and once I get I squared in the denominator, when I multiply my denominator by I, I'll get I squared in the denominator, and I can replace that I squared with -1. So this is the reason I multiplied my fraction by I. Now we know that the general form of the complex number is a plus n minus bi, where a is the real part and bi is the imaginary part. And I need to write my final answer in the form of a plus n minus bi. So first of all, I'm going to divide both the terms by 10. So this will be equal to -5I over 10 and then plus 1/10. Now I can reduce this -5/10 to -1/2. So this will be -1/2 I plus 1/10. Since I need to write my final answer in this form, my real part should come first and the imaginary part should be second. I'm going to write my real part first, which is 1/10, and then I'm going to write my imaginary part. Since it's -1/2 I, make sure you bring that along with the sign. So this is -1/2 I, and this is going to be my final answer. Now let's take a look at this example. If you notice that I have an I in the denominator, and we know that we cannot have an imaginary number I in the denominator. So first thing we need to do is to eliminate this I from the denominator. To do that, I would have to multiply my denominator by the complex conjugate. Basically, I need to multiply my fraction by the complex conjugate of the denominator. So my denominator is 3 minus 9i. What will be the complex conjugate of 3 minus 9i? The complex conjugate of 3 minus 9i will be 3 plus 9i. So basically, complex conjugate is formed by changing the sign between the two terms in a complex number. So you see that this was my complex number. All I did is I changed the sign between these two terms and I got 3 plus 9i. So the complex conjugate of 3 minus 9i will be 3 plus 9i. Now since I multiplied my denominator by the complex conjugate, I would also have to multiply my numerator by 3 plus 9i. And now all we need to do is to use the distributive property to distribute this 2i inside the parentheses. So let's do that. This will be 2i times 3 will give me 6i. Then 2i times 9i is going to give me 18i squared. Then 3 times 3 is going to give me 9. 3 times positive 9i is going to give me 27i, positive 27i. Then negative 9i times 3 is going to give me negative 27i. And then negative 9i times positive 9i is going to give me negative 81i squared. Notice that the middle terms cancel out each other. Positive 27i and negative 27i is going to cancel out each other. I'm going to replace I squared with negative 1. So here this will be 6i plus 18 times negative 1 divided by 9 minus 81. Again, in place of I squared, I'll write negative 1 here. So let's simplify this. This will be 6i. Positive 18 times negative 1 will be negative 18 all over 9. Negative 81 times negative 1 is going to be positive 81. And notice that I don't have any imaginary number in the denominator now. So when you multiply a complex number by its complex conjugate, then it produces a value which is real. Like here we got 9 plus 81, we don't have I here. So now what we're going to do is we're going to simplify this more. This will be 6i minus 18 over 9 plus 81 is going to be 90. And we can divide both the numbers by 90. So this is going to be 6i over 90 minus 18 over 90. And we know that we need to write our final answer in the general form, which is a plus and minus bi. And I need my real part first and then the imaginary part. In this, the real part is negative 18 over 90. Make sure you bring that along with the sign. Now, negative 18 over 90 can be reduced to negative 1/5. So I'll write this first, negative 1/5, because I need to write my real part first. And then I'll write my imaginary part. Now, 6i over 90 can be reduced to 1 over 15i. So this is going to be plus 1 over 15i. And notice that my final answer exactly matches with the general form of the complex numbers. I hope you feel comfortable in dividing complex numbers now. That's all in this video. Thank you so much for watching. If you are new to this channel and want to see more videos on other math topics, be sure to subscribe down below and share it with your friends. See you in the next video.